Morning everybody, here we are ready for some more maths on Tuesday. So we're going to start with our warm up today and we're going to do another Fab 4. Now I thought we'd do a bit of a recap of our BIDMAS for today's Fab 4. So remember, you might need to remind yourself of BIDMAS: brackets, indices, division, multiplication, addition and subtraction. Now some of these are quite tricky, so think really carefully about the order. Okay, so pause your video, give yourself 4 minutes and come back for some answers. All right, okay, so here we go. So for the first one then, BIDMAS, what's the first thing that has to be done in question 1? Well, division comes before multiplication. So we have to do 24 divided by 6 first, which gives us an answer of 4. And then we times that by 5. So our answer is 20. Question number 2, indices comes first, doesn't it, over here? So we need to figure out what is 3 squared. Well, that is 9, 3 times 3. Now, addition or division? Well, division comes first, so we've got to do 27 divided by 9, which gives us an answer of 3. So then the final part is to add 26 to 3, which gives us an answer of 29. Number 3, obviously brackets comes first. So we've got 9 times 4, which is 36. So we've got to do 50 take away 36, which gives an answer of 14. And finally here, indices come first, so you can calculate the amounts of the indices first. So 5 cubed, now remember that's 5 times 5 times 5, so that's actually 125. 4 squared is 16. Now, we've then got something in the brackets here. So 5 times 4 is 20. So now we can do the other parts of our calculation. So we can do 25 add 16, which gives us 136. Sorry, ignore me. My brain's not switched on. So what I'm trying to say is I would do 125 add 10, which would give me 135. And then I would add 6, which would give me 141. And then I would take away 20, which would give me an answer of 121. Sorry, I hope I didn't confuse you there. So just remember the way that we have to organise all the different sections there, particularly that last one where you had to calculate what was in the brackets, then calculate each indice and then add and then finally take away. All right, today we're carrying on with looking at area and perimeter. We're going to be comparing area with perimeter today. So our wealth, we need to be able to calculate the area of a shape. We need to be able to calculate the perimeter of a shape, and we can use factors to help us find other shapes with a similar or same area. Okay, so let's have a look at our Discover today. We've got Lexi and Max drawing 2 shapes. I've tried to enlarge them so you can see them a little bit better. Now the question's asking us today, what is the same about the shapes they've drawn and what is different? Well, obviously what's different is one is a square and one is a rectangle. The square has all the sides the same, and a rectangle has 2 sets of sides which are the same. What else can we find though that is the same and different about these shapes? Well, let's first of all write down the lengths of them. So Lexi's shape, you can see it tells between each dot is 1 centimetre. Now if we count across here, Lexi's is 6 centimetres wide and 6 centimetres long, so it's the same because it's a square. Max, his width across the top here is 4 centimetres, and the length, if we count them all, there are 9 centimetres there. So remember when we worked out the area of a shape, can you remember how we calculate the area? Well, we do the length and we multiply it by the width. So let's have a look then. So Lexi, the area of her shape is 6 times 6, isn't it? So we've got 6 times 6, which equals 36. Now, can you remember with our units, if it's the area, it's centimetres squared. Now let's do the same for Max. Okay, so the area of his shape, that's going to be this time 4 times 9 centimetres. Now 4 nines are also 36 and centimetres cubed. So there is something else which is the same. They have the same area. Now, what about if I were to ask you, how do we calculate the perimeter of a shape? Can you remember? Now, I always think about this like in a prison, the perimeter fence. The perimeter fence goes all the way around the outside of the prison. So this is where we are adding all the edges together. So imagine that your shape is like a field and you want to put a fence going all the way around the field and you want to know how long that fence has got to be. So you really then, so let's have a look at Lexi's. I'm going to do it over this side next to it. So the perimeter, you can either think about by adding 6, add 6, add 6, add 6, because there's 4 sides, which is 6, or in this case, we could just do 4 times 6 because they're all the same length. So that would give us an answer of 24 centimetres. Now, what do you spot that's different from the units I'm using between perimeter and area? Can you see that perimeter doesn't have to have a squared because it's not the total coverage of the inside, it's just the outside length. So for perimeter, we just use the standard measurement unit. So in this case, it's centimetres. Now, Max's area is we're going to calculate that in a slightly different way because he has got the width is 4 centimetres and there are 2 times that. So we could do 4 times 2, which is 8. And then the other length is 9 times 2 because there's 2 of those, which is 18. And then we've got to add these 2 together. Now, once we add those together, that's going to give us the perimeter of this shape. So 18 add 8, so that's going to give us an answer of 26 centimetres. So we can see then that Lexi's square, her perimeter is 24 centimetres, but Max's rectangle's perimeter is 26 centimetres. So there is something that is different. The perimeter of each shape are different, although the area of them for both of them is the same. So that can happen, that sometimes the area of the shape can be same, but the perimeters can be different. Okay. All right, now Max is going to draw another rectangle on the grid. It has the same area, but a different perimeter to the other 2 shapes. What could the dimensions of the shape be? Now let's flick back. So we can see that the area was 36 centimetres. So shall we write that down over here? 36 centimetres squared. Now, in order to find other formations of a shape to make that area, you can think about factor pairs, because if you think about it, on the other page we looked at, we had one that was 6 times 6, because that gave 36 centimetres squared. We had another one that was 9 times 4, because it gave 36 centimetres squared. What are the factors of 36? Do we know? How else can we calculate 36 centimetres squared? Well, we could do 18 times 2. We could do 36 times 1. And that will give us another formation of the shape. This one I've drawn here has got 3 times 12. So actually there's lots of factor pairs for 36, because 3 times 12, that would give an inside area of 36 centimetres squared. So they've got different lengths, okay, to the previous shapes, but the same area. Now, how would I calculate? Pause the video and calculate the perimeter of this for me. Now, remember, that's the total of all the edges on the outside. Okay, so you could have done this in 2 different ways. So the perimeter, this is the long way, is basically adding all the lengths of the outside edges. So you've got to make sure maybe that you've written them all on there to see. So some people will do 12, add 12, add 3, add 3, which is fine, you'll get the same answer. But do you see you've got 2 lengths that are the same? So you could do 12 times 2, add 3 times 2. Might be a bit quicker. So 12 times 2 is 24, 3 times 2 is 6. Add them both together and the perimeter of this shape would be 30 centimetres. So if you're happiest adding all the outside edges, that's fine. If you want to do the short method where you're doing the length times 2, add the width times 2, that's great. Let's have a look at this thing together then. It's asking us to do just that. Work out the area and perimeter of each shape below. So for A, let's have a look at this one together. We've got the area of A. Now the area of A, you can see we've got to do the length times the width. So we've got 8 times by 3. 8 times 3 is 24 centimetres cubed. Now the perimeter, do you remember, if you want to, you can write the other lengths on to help you. Okay, now we've got something times 2 plus something times 2. Well, we've got 8 centimetres times 2, haven't we? Plus 3 centimetres times 2. So 8 times 2 is 16. 3 times 2 is 6. So that's going to give us a perimeter of 22 centimetres. Now have a pause and see if you can do B, all right, and then come back. Do see if you can. If not, I'm going to explain how to do that in a minute. All right then, so for B, let's look at our area. So we've got 1, 2, 3, 4 on the width, and we've got 1, 2, 3, 4, 5, 6 on the width, sorry, on the length. So we've got here 6 times by 4 for our area, which gives us an area of 24 centimetres squared. Now for our perimeter this time, we're going to do 6 times 2, because that's twice the length, and we're going to add it to 4 times 2, because that's twice the width. So 6 times 2 is 12, 4 times 2 is 8. So this one has got a perimeter of 20 centimetres. Now, how do we calculate the area for C? What we do for this case is we can divide the shape into 2 known shapes. This is a compound shape as it stands at the moment, because it's got all different lengths on there, and it is not a regular shape that we can give a name to, like a square or a rectangle or a triangle. It's called a compound shape. Now with a compound shape, to work out the area, we divide it or split it up into shapes that we know. So can you see I put a line down here? So really what I've done, I've changed it into a rectangle here, and I've changed it into a square here. So when I want to work out the areas, I can work out the area of this bit first. So this would be 1, 2, 3, 4, 5. This length is 5, and this is 3 centimetres. So 5 times 3 is 15 centimetres squared. This one is 3 across here and 3 down here. So 3 times 3 is 9 centimetres squared. So then for the area, I can add those two together. So 15 add 9 gives us an area of 24 centimetres squared. Well, what do we notice about all those shapes? They've all got the same area. Now, what about the perimeter for this one? Now, the perimeter, the important thing to remember, it is the total of the outside edges. So this line that I've added in the middle now, to separate the two shapes just here, we almost need to just ignore that. And when we're working out the perimeter, we are just going around the outside like so and adding those edges together. So we would do 3, add 5, which would give us 8. And then there's another, it depends how you do it here. This all together along this edge is 6. So we had 8 altogether, add 6, that gives us 14. Add another 3, that gives us 17. Add another 3, that gives us 20. Add another 2 just here up this side, that gives us 22 centimetres as a perimeter for this one. So can you see actually in these cases, none of them have a perimeter in an area that is the same. Their perimeters are always different to the area. And these shapes, even though they all have the same area, they all have a different perimeter, a different total to all the outside edges. Now, what about this one? Look at these shapes. What do you notice about the area and perimeter of each of these shapes? Now, if I move my face out of the way from here, you pause it and have a go. I'd like you to have a go at calculating the area and perimeter of all of those shapes and see what you notice, and then come back for the answers. Okay, so here we go. So shape A, look, has an area of 28 centimetres squared and a perimeter of 24 centimetres. Shape B has an area of 28 centimetres squared and a perimeter of 26 centimetres. Shape C, the answer seems to have been there for the perimeter, which was 32, and the area was 28 centimetres squared. So what do we notice about these shapes? Again, the area is all the same, but the perimeters are different. Now, with some of these, when you were calculating the perimeter, you have to make sure that you're calculating every outside edge. So for B here, you would have to go all the way around each part to make sure that you're getting all of those lengths in. So for that one, they're all the ones you would need to add, but we wouldn't add this length down the middle because that's inside the shape now. So if you're a bit confused with that, just make sure perimeter is all the way around the outside. Okay, so today's work. You're working on area and perimeter part 1 in Power Maths, pages 120 to 122. This, you've just got to keep thinking area is length times width, perimeter, outside edge, and do the comparison to see how you get on. If you get it finished, here is the challenge that you can come back to at the end. Good luck, and I'll see you tomorrow.